Let f of x be equal to the square root of 4x minus 3, and let c be the number that satisfies the mean value theorem for f on the closed interval between 1 and 3, or 1 is less than or equal to x is less than or equal to 3. What is c? So let's just remind ourselves what it means for c to be the number that satisfies the mean value theorem for f. This means that over this interval, c is a point, x equals c is a point where the slope of the tangent line at x equals c, so I could write f prime of c, so that is the slope of the tangent line when x is equal to c. This is equal to the slope of the secant line that connects these 2 points. So this is going to be equal to, see, the slope of the secant line that connects the points 3 f of 3 and 1 f of 1. So it's going to be f of 3 minus f of 1 over 3 minus 1. And if you wanted to think about what this means visually, it would look something like this. So if this is our x-axis, and this is 1, 2, actually let me spread it out a little bit more. 1, 2, and 3. And so you have 1 comma f of 1 right over there. So that is at the point 1 comma f of 1. And we could evaluate that. Actually, what? That's 1 comma 1, right? So that's going to be at the point 1 comma 1. And then you have the point 3 comma, let's see, you're going to have 4 times 3 is 12, minus 3 is 9. So it's going to be 3 comma 3. 3 comma 3. So maybe it's right over there. 3 comma 3, and it might look, the curve might look something like this. So it might look something like that. So if you think about the slope of the line that connects these 2 points, so this line that connects those 2 points, all the mean value theorem, I'm going to do that in a different color, all the mean value theorem tells us is that there's a point between 1 and 3 where the slope of the tangent line has the exact same slope. So if I were to eyeball it, it looks like it's right around there, although we are actually going to solve for it. So some point where the slope of the tangent line is equal to the slope of the line that connects these 2 endpoints and their corresponding function values. So that is c. That would be c right over there. So really we just have to solve this. So let's first just find out what f prime of x is, and then we could substitute a c in there, and then we can evaluate this on the right-hand side. So I'm going to rewrite f of x. F of x is equal to, and I'm going to write it as 4x to the minus 3 to the 1/2 power. It makes it a little bit more obvious that we can apply the power rule and the chain rule here. So f prime of x is going to be the derivative of 4x minus 3 to the 1/2 with respect to 4x minus 3. So that is going to be 1/2 times 4x minus 3 to the negative 1/2. And then we're going to multiply that times the derivative of 4x minus 3 with respect to x. Well, derivative of 4x with respect to x is just 4, and the derivative of negative 3 with respect to x, well, that's just going to be 0. So the derivative of 4x minus 3 with respect to x is 4. So times 4. So f prime of x is equal to 4 times 1/2, which is 2, over the square root of 4x minus 3. 4x minus 3 to the 1/2 would just be the square root of 4x minus 3, but it's the negative 1/2. So we're going to put it in the denominator right over here. And so f prime of c, we could rewrite this as 2 over the square root of 4c minus 3. And what is that going to be equal to? That is going to be equal to, let's see, f of 3 we already figured out is 3. F of 1 we already figured out is 1. And so we get 3 minus 1 over 3 minus 1. Well, that's going to be 2 over 2, which is equal to 1. So there's some point between 1 and 3 where the derivative at that point, the slope of the tangent line, is equal to 1. So let's see if we can solve this thing right over here. Well, we can multiply both sides of this by 4c, by the square root of 4c minus 3. And so then we are going to get we're going to get 2 is equal to the square root of 4c minus 3. All I did is multiplied both sides of this by square root of 4c minus 3 to get rid of this in the denominator. And so let's see, now to get rid of the radical, we can square both sides. And so, actually, let me just show that. So now we can square both sides. So we get 4 is equal to 4c minus 3. Add 3 to both sides. 7 is equal to 4c. And then divide both sides by 4. I'll go right here to do it. You're going to get c is equal to 7/4. C is equal to 7 over 4, which is equal to 1 3/4, or we could view this as 1.75. So actually, the c value is a little bit closer. I hand drew this. It's closer to about right over there on our diagram. And actually, that looks pretty close. That actually looks pretty good. I just hand drew this curve, so it's definitely not exact. But anyway, hopefully that gives you a sense of what's going on here. We're just saying, hey, the mean value theorem gives us some c where the slope of the tangent line is the same as the slope of the line that connects 1 f of 1 and 3 f of 3.